Hi, my name is Ben Stevens, and this is my demonstration video for the CompEng 2DP4 final project. For this particular project, we receive a signal from the ADXL337 accelerometer, as shown here, and convert it to an angle. This angle represents the angle at which the accelerometer has been rotated from the originating flat surface. The Arduino Extreme comes into play as the ADC used for this circuit, and with the help of the CodeWarrior IDE, the Arduino converts the analog input signal from the accelerometer into a meaningful angle output through a series of calculations and conversions, which are used to calibrate and calculate the angle. The output signal from the accelerometer is created by using a single axis tilt sensor and using gravity along with angle measurements to create an analog signal output. For the assignments I was given, I was assigned A4 as my output for the X acceleration from this accelerometer. I chose to use A5 for the Y acceleration. These two ports can be shown at the very end of the Arduino there. And I'll get my serial number in while you can see it. It's 20,000 right there. Yeah. I was also assigned a 10-bit resolution and an 8 megahertz bus speed. The serial communication rate that I decided to use was 38,400, and this is also known as the baud value. The reasoning for this choice was through calculations shown in the report, this rate showed little to no error, and this proved to be true through trial and error in testing, as I wanted to use the largest possible communication rate that still worked and was consistent with little error. Okay, so now I'm just going to show you the general setup, and right now I have the code running, which is why the lights are showing. They're going to read as follows. So it's going to be the least significant bit is on your right, and the most significant bit is on your left. Okay, so let's get started with the demonstration then. So as we can see right here, we are receiving live updates of the angle measurement that I've acquired in CodeWarrior. This angle measurement was calculated by me through the formula given to us on the project specifications, which consists of arcsine and a bunch of other things to make that formula. Now, as we can see, obviously the lights are not at 0 because it's not perfectly calibrated, but it's never going to be more than about 2 or 3 degrees. And we can see as we begin to rotate, we see the angle increase. In both directions, we will see that. Also, when we change our mode from X to Y, we'll notice that the acceleration and the angle change with Y. Okay. And if we look at our serial communication here, and I change the push button, this is the button for serial communication. The serial communication halts. So now we know that those are all working. Okay, so if we quit this MATLAB window, we're now going to see the output voltage. So I'm going to go into my program and change my serial mode variable, which I have discussed in my report. So I'm going to change this to 2 so that I'm outputting voltage instead. Once I do this, I can go into MATLAB again, choose this MATLAB code, which is called, this one is for the voltage. And we're instead going to run it with this one. So let's run it. Okay. Sorry, I'm just going to have to replug this in. There we go. And let's run it. So now, if we run this one, we're going to see our voltage against time. It's still being plotted on the theta versus time graph, but we notice that with the angle change, it goes up, and we get the voltage values that we expect. I'm rotating it at about a 30-40 degree angle right now. So that's what we expect. And we would just see voltage on the y-axis here if I were to restart MATLAB. So thank you for watching, and yeah, have a good one.